Hi there. Welcome to another episode of Space Nuts. I'm your host, Andrew Dunkley. As always, it is great to have your company. Hope you're well. And I hope you can stay with us because we are going to give you yet another asteroid update. Yes, it's still in the news. I was reading stories online over the weekend and it was all doom and gloom. 2024 YR4. It's going to kill us all. Well, let's find out the truth. We're also going to answer a question. It's not the definitive answer, but it's the answer at this point in time. Are we alone? And the reason? New data that's been released. SpaceX has got itself into the news again for all the wrong reasons. And there might be another moon in our solar system that harbors a liquid ocean. We'll tell you which one it is on this episode of Space Nuts.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
And he is back for more. It is Jonti Horner, Professor of Astrophysics at the University of Southern Queensland. Jonti, hello.
Good afternoon. How are you going?
I am well. Good to see you. And Jonti warned me that we might hear some dog interruption, not from the dog star, but from the dogs.
Yes.
When the other half turns up because they get very excited.
We've been really excited at people walking down the road. So
that's
maybe you can hear them, maybe you can't. But I'm hearing woofle.
The filters might be stopping it from getting through to the recording. Sometimes that happens. But well, we've heard Geordie many times on the podcast at Fred's house. So yes, not unusual. And we don't mind. We've been interrupted by all sorts of creatures on this show over the years. Let's start off with yet another update on our favourite asteroid. It might not be our favourite if you read the popular press. 2024 YR4. What's the latest?
Well, the latest, long and short, is that catastrophe is averted. It is almost certainly not going to hit us. And this has come around a little bit quicker than I was expecting, actually, but I've seen some beautiful visualizations released by both European Space Agency and NASA over the last few days that have shown what's going on.
Yep.
So I mentioned on the previous episodes that we found this object back on the 27th of December. They immediately found some old images that went back to the 25th of December when it was closest to the Earth. And people have been observing it pretty full on ever since, those that could do, because it's quite small, quite faint, as it receded from the Earth. And end of January, the odds of it hitting the Earth got high enough in 2032, in 8 years' time, that it was flagged up as being potentially threatening, and it got the second highest ever rating on the Palermo scale. So basically, this thing is something to watch out for. We're not saying it's going to hit the Earth, but we need more data. As time's gone on since then, we've got more and more data, and for a while, the probability of it hitting us on that date, on the 22nd of December 2032, was increasing. And that was exactly what you'd expect. So you get more observations, which means our knowledge of where it will be on that fateful day gets better. So the area of uncertainty on where it will be gets smaller. So you're shrinking the volume of space where the asteroid could be. And if the Earth stays in that area, the Earth becomes a bigger fraction of that total area. So it's more likely to be hit.
Yep.
And what I said at the time was eventually we'd get enough observations that the Earth could potentially fall outside that area. So the area would shrink enough that the Earth kind of popped out of it, fell out onto the other side. And that's what's happened over the last few days. Now, the Earth is not totally and absolutely out of the firing line, but it's almost as good as. And I'm sure within a day or two, it will drop to absolutely zero. So as of the time we're recording this, which is February the 25th, the latest probability of an impact is 2.7 times 10 to the minus 5, which means 0.0027%, or 1 in 37,000.
Right.
Now, given that last week we were talking about 1 in 33, that's a very dramatic change. And that's because the area that the object is going to be in has shrunk and shrunk and shrunk, and the Earth has essentially popped out of the outside. And that's what these beautiful visualizations that are popping up online are showing. An interesting part of this, though, is that while Earth is out of the crosshairs, the moon is still in the crosshairs.
Ooh.
So there remains a possibility that this thing could hit the moon, but the probability of an impact on the moon is still pretty low. So it isn't a case of we're saying the Earth is spared, watch out anybody who's part of Project Artemis, walking around on the moon in 8 years' time, if that happens.
Yeah.
Rather, it's just that the moon still hasn't fallen out of that area yet, but I'd anticipate it probably will do. So the most likely outcome is that this thing will come close, but it's not going to be that close.
Okay. Now, what if it did hit the moon? What would be the effect? Would it just make a mighty big crater?
It'd make not even that mighty, not even that big. A good rule of thumb on the Earth is that if something solid makes it to the surface of the Earth, the crater that thing will create is going to be, to first order, 19 times bigger than the impactor. Little bit of wiggle room in there. Obviously, a different material for the impactor would have an impact, a different speed would have an impact. But first order, it's about a rule of 19. I think that changes slightly from body to body, but not hugely, because it's still the physics of rock hitting rock or metal hitting rock. What that means is if this thing is the size of the best estimates, which is about 55 meters, then you're looking at about a 1 kilometer crater, which, is substantial. It's big enough for us to observe, but it's nowhere near the biggest anywhere out there. It's probably not big enough that a substantial amount of material will be ejected from the moon to reach us. But people have tried to fearmonger that a little bit. I've seen a few posts from people online saying, if it hits the moon, the Earth will get hit by a load of debris. Realistically, not much debris would reach the Earth. So we might get a little bit burning up in the atmosphere, but we wouldn't even probably notice, because this thing's fairly small. I've seen some studies arguing that you need an impactor at least 1 kilometer across to eject enough material from the moon for us to really pick it up and notice it from the point of view of looking up.
Okay. All right. Well, we've got how long to wait?
Just under 8 years. So
Yes.
we can revisit this in the future when Fred is once again looking at Aurora in Scandinavia.
Yes. Why not? All right. So the good news is the odds have plummeted, and despite what I read in I don't know how many news outlets on Sunday, the story is very, very different today.
Yeah, it's a very fast-moving story, and if you can find these little animations online, they're worth looking at, because it shows you a line that is basically all the possible places the asteroid could be in. That's the result of lots of simulations with slightly different initial conditions that all match within our uncertainty where the object is currently. And you get this long stretched out line, and then with every day of new observations, that line gets shorter and shorter and shorter. And now the Earth is right on the very end of it, barely touched by any of them. And I'm sure tomorrow the Earth will be scot-free.
Okay. That's good news. Very good news.
3, 2, 1.
Space nuts.
Now, to a question that we do get from time to time from our audience asking about whether or not we are alone in the universe. I suppose that is one of the big questions yet to be answered as far as the wider, humanity is concerned. That question has got new data attached to it, which is very interesting because of the way it's been collected. And the downside is the result at this point in time. But yes, are we alone so far? I think that's the best answer, isn't it?
It is. So there are two different ways that we'll look to answer this question, and two different things we're looking for. One is just to look for any evidence of any kind of life. And we're doing that within the solar system, and we're doing it outside the solar system by looking for subtle indications that there could be life in various places. And that will probably amount to finding something that's out of equilibrium that shouldn't be there. A good example being the phosphine observations on Venus a few years ago that raised a lot of excitement, but are probably not actual life, but we don't know. It's finding something out of place and inferring that life is the best explanation that could exist for it. And that's where we're going to be doing a lot of work in the coming decade or two, looking at planets around other stars. That is a search for any life, particularly simple life. And I think, as a little bit of an aside, I think we're more likely to find simple life before we find complex life, just because of the amount of available real estate and the amount of available time. So if you look back at the history of the Earth, it seems to be accepted that we've had life on Earth for at least 3,500 million years. The oldest fossils are found in the Pilbara in Western Australia. That's really kind of cool. We've only had complex life on Earth for about 500 million years. So I think there are some studies this week I saw that suggest it might have been around a bit longer than that. So what that means is if you could do something really bizarre and make a dice with 7 sides, which I've had somebody tell me is almost impossible to do, but, get a 7-sided die instead of a 6-sided die, and roll that die, you're looking at the Earth at some point in that 3.5 billion year period. And only if you rolled a 7 would you see the Earth when there was complex life. So 6 times out of 7 you'd hit us when there's simple life. The other side of it is if you look at the habitats that life occupies on Earth, there are a far, 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 far greater amount of habitats where simple life can thrive than where complex life can thrive. If I took you up to 40,000 feet and let go, you wouldn't so much fly as plummet, in the immortal words of Monty Python. But we find bacteria up there. If I drop you in, one of the superheated lakes in Yellowstone, you'd dissolve quicker than people could pull you out, and that would be unpleasant, but we find bacteria there. So there's a far wider envelope of environments where you could find simple life than where you'd find complex life. All of that is based on the caveat that we're looking at life like Earth life, of course. And that's a very big caveat. It's an assumption that is implicit in what most people discuss. And I think it's important to make it explicit. You watch Star Trek and you imagine molten metal men wandering around on magma planets and things like this and intelligent hydrogen clouds. But when we're looking for things like life, it makes more sense to look for something we know can exist than for something that we could speculate might exist. And so we know of Earth life, so that forms our first template, and that will inform our first search, even though you'd admit that there could be other kinds of life out there. And with Earth life as a template, you'd argue that for most of the time there's been life on Earth, we only had simple life. And in most of the places and environments you can find life on Earth, you can only find simple life. So that suggests to me simple life will be more common than complex life in the cosmos. And we're more likely to find that. Of course, there's that famous saying that the only prediction you can make that is accurate is that all predictions will be wrong. So when we do find life, please don't shout at me, but that's kind of where I take it. But coming back to the story, after I get derailed and go on a diversion, this story is looking at the other way we can search for life, which is the one that has the potential for greater reward and greater excitement, but a lower potential for success. And that's the search for extraterrestrial intelligence, or SETI, or the associated search for extraterrestrial technology. So this is looking, instead of looking for any life, it's looking for life that has technology at least as advanced as ours, that is in some way making itself known to the cosmos. Now, to some degree, I've heard this described as searching for a needle in a haystack when you don't know what a haystack is and you've never seen a needle. It's trying to listen for something that another species that has technology would create that we could identify as being definitively caused by life. And because a bit like the science fiction analogy earlier on, we can imagine a wide variety of things. What this kind of work tends to do is focus on the things that we as humanity do that we could detect if we were elsewhere in the cosmos with sufficiently advanced technology. And the one that often gets a hat hung on it and said, this is one we'll look at, is a search for broadcasts. I guess like this podcast is when it goes out on ABC and it's broadcast on the radio, bits of it, then that's been broadcast in all directions with a certain amount of power so that when somebody tunes in their car, they can listen to it. And that means that this broadcast will be winging its way out into space, and somebody with a sufficiently sensitive radio receiver pointed at the Earth at just the right time could tune in and tell me that I'm talking rubbish, essentially. That's probably what would happen. Or they'd churn over and say, look, please don't cancel neighbours. That needs to run on and on and on. Now, you make an assumption that other technologically advanced species, if they exist, would follow a similar technology route to us. Then that suggests that there'll be a period of time when those species too broadcast to the cosmos. Now, the analogy I use a little bit here is a bit like a toddler in a cave screaming its lungs out. Eventually, they'll learn to control themselves. So we're already finding on Earth that we are throwing less signal into space than we used to because it's more efficient to broadcast point to point or through cables. So a lot of people will listen to this through their wired internet that comes through cables or through, heaven forfend, through Starlink, where it's point to point. So there's not much wasted. And so eventually people are predicting the Earth will go radio quiet again. But this is one way that we know we as a society are making ourselves obvious to aliens that are out there, if they exist and if they've got the technology to listen in. So that has inspired a lot of people to turn the telescopes skyward with radio telescopes and listen to see if we can get alien signals. And that's been fundamentally what SETI is. It's been really useful to us in the Australian astronomy community because it's the main reason that the Parkes radio telescope is still operating, courtesy of the Breakthrough Listen initiative. But people have been listening, and they've tried listening at all sorts of different frequencies. They've done targeted searches looking at a few stars like the sun. They've also piggybacked off other surveys where people are getting radio observations for a totally different reason, and the SETI people get hold of those observations and check them just to see whether there's a TV broadcast buried in that, essentially. But the challenge of doing this historically is that it's very labor-intensive, because there's a lot of different radio sources out there that are natural, and you need to rule them out. You find a signal, it looks weird, but if it's natural, it's not aliens. So you've got to rule that out. You've then got a whole heap of, human-generated signals that you've got to rule out, and they can be harder because it could be a spy satellite's gone through. And nobody's going to say to you, well, actually, no, you've called us. That was my spy satellite. We were trying to watch some filming Neighbours. I don't know why I've got Neighbours on the mind, given that I've never watched the thing, but there you go.
I think it's been cancelled.
I think that's what it is. I saw that story, and given that my joke about, searching for aliens is that they'll come and tell us to turn it off and stop it, seems ironic. But anyway, it could be a spy satellite looking down. It could be as simple as a microwave in the next building that somebody was warming their dinner up. And that has actually happened before. People have detected microwaves in other buildings. So it's really, really complicated. And what that means is that a lot of these efforts to look for alien technology and alien signals have been limited by the human resources available to them. Which brings us finally to this new survey. And I know I've gone in a very long roundabout route there. There's this incredible radio facility called the Very Large Array over in the US that the square kilometre array is going to be bigger and better, and we're going to have that in Australia so we can wave a flag and say woohoo. But the Very Large Array has been doing incredible observations for a very long time. If I remember correctly, those who like the movie Contact, which is based on the Carl Sagan book, some of the scenes were shot at the Very Large Array, if I remember right. So if I'm wrong, again, please don't shout too loudly, but my memory is that that's the Very Large Array that features in that film.
Yeah.
Anyway, the Very Large Array has spent a huge amount of time scanning particularly the Northern Hemisphere sky, because it's a Northern Hemisphere facility, doing all sorts of radio astronomy observations of all sorts of things. A team has developed something that they call COSMIC. Now, I'm just finding the acronym here. COSMIC is a commensal open source multimode interferometric cluster, which is a mouthful, which is why they call it COSMIC. It's a very large computer and software setup that essentially attempts to automate that complex process that I described, where you've got to rule out all of the possible signals. It's been heavily built and coded so that every single observation that they get, they can run through this pipeline, and it will say, does it have anything in it that could look like it's of an alien origin? Filter it down heavily. If it passes that first test, then you run another test that said, could any astronomical phenomenon explain this? If it fails that test, it gets thrown out. Next, it says, could it be anything that we know of that is of human origin? And if it fails that test, it's thrown out. So it filters it down to give the people who do the checking a tiny short list rather than an incredible long list. Now, doing that, they've been able to take 920,000 different observational pointings from the Very Large Array. That's 920,000 different radio observations of different parts of the night sky, and analyze them one after another, looking for any signal of aliens. And this does clever things. It looks for a signal that is localized on the sky, so it looks like it's coming from one particular star. It even looks to check for the redshift and the blue shift of that signal, because if it's on a planet going around that star, the frequency will change a little bit as a result of the planet's movement around the star. So it digs into a whole heap of things to do these filters and allows them to throw a lot of things away. So this has surveyed 82% of the entire Northern Hemisphere night sky, like I say, actually 950,000 pointings of the telescope. And what they've found was they flagged a few interesting signals. None of them turn out to be aliens. So after all this work, after all this waffle, after all my diversions, the result is we found nothing. But that's the risk you run, because at the end of the day, if technologically advanced life is out there, there's no guarantee it will broadcast this way. As I said earlier on, we're probably going to be radio quiet again within just a few decades, even if we don't wipe ourselves out. So we'll stop broadcasting. So then there'll be a single little shell of radio emissions about 100 light years wide, expanding into space around the sun. And if you're in that 100-year window, you'll be able to tune in and listen to us. If you're too early or too late, you won't hear. Now, 100 years is a long time to me and you, and I'd love to think I'll last 100 years on this planet. But in the scale of the cosmos, our Earth has had life on it for 3,500 million years, and only for 100 years of that has the Earth had a signal. So that's a 1 in 35 million chance of looking at Earth while it's had life and hearing our radio broadcasts. And that's lower odds than the asteroid hitting us.
Yeah. It's also lower odds of winning Powerball. Anyway. Yeah, it's an interesting story in that, they've found a new way, but they haven't found anything yet, and they have had a lot of targets, but that doesn't mean it's not out there somewhere.
Absolutely.
It's not saying there isn't intelligent life, but I do agree with you that finding microbial life or single-cell life of some kind is in the foreseeable future, and we've got missions headed out in the very near future to try and find just that.
We do. We might even talk about those in the Q&A episode later on.
We might do that. But the probability of finding life in our own solar system is pretty reasonable. I wouldn't like to put a number on it, but I think that the odds are pretty good. Fred also feels the same way. So even that would be one of the greatest discoveries in human history, because so far we only know one place where there is life, and that's us. So time will tell, but when they get the supercalifragilistic array up and running, that might make
then we might get tuning. And people will be applying these same kind of techniques to the square kilometre array once it's up now, because it's the obvious way to do things, especially when you've got good computing power. But I think the other thing this highlights, which I think astronomy in general does really well, is the importance of reporting no results or negative results. Now, once upon a time in the distant past, I dated a biologist, and there was a real problem in her field that when people did an experiment and they found nothing, they couldn't really get it published. Either the company that was sponsoring it wasn't very keen on them publishing it, or the journal said, well, look, you've not found anything, so we're not going to report it. Now, let's say you do an experiment that isn't going to find anything, but it's not that accurate. So there's a small uncertainty in your results. You find nothing, you don't publish it, so someone else goes away and does the same experiment. They find nothing, but eventually, due to the way statistics work, someone might get a signal that looks interesting and they'll publish it. And you get a almost misleading idea of whether this thing happens or not, whether this thing works or not. And this was something that she was concerned with. She ended up leaving the field. Yeah. And it's a real challenge that you face in a lot of disciplines, is that it is much, much easier to publish a result that is explicitly, we found something. We observed something. There is a signal here. We found it. But publishing the opposite of that, which is we looked and found nothing, is very hard. And astronomy has done and continues to do a really good job of people being able to publish the results when they find nothing. And we find this in the exoplanet game. We observe a star, we don't find any planets, but we'll include it in a paper and we'll publish the data to say, we watched this star for a decade and nothing happened. And the beauty is that makes that data public. It means that other people with similar levels of equipment to us don't waste their time. But it also means that you've got that data there so that somebody with higher resolution observations in future can use your data as well as part of their analysis. And it's a really critical part of science to be able to report what you didn't find. And I think it doesn't occur to me that often, but there's a certain amount of pride, I think, in the fact that astronomy remains a discipline where you can try to look for something and fail and still get your work published and still progress your career, because you've still advanced our knowledge, because you've lowered the possibilities, or you've lowered the phase space of what could be by ruling out what can't be.
And there's also the fact that what we're witnessing now is new studies and new papers being published based on historical data, historical gathering of information. and they hadn't been able to analyze it the way they can now because the technology's improved. So they've been able to do studies now based on information that was published 20, 30 years ago when the technology was far inferior. So you can use those papers for better purposes.
And that's the point we will come back to with our final story in this, I think. So it's a good time. I also see that Fred has returned.
Hello, Fred Watson. Here he is.
Hello. How are you, gentlemen?
We are well. It's nice to see you. We knew you were going to drop in. We thought we'd just surprise everyone. We didn't preempt it because I also considered the possibility you might forgot.
Yes, I considered that as well. Jet lag does funny things to your brain.
Yes, indeed it does. You came in right at the end of this story, and if you'd like to read up on that search for extraterrestrials, the new way of doing it that has found nothing yet, you can do that at space.com.
Okay, we checked all 4 systems and keying with a go.
Space Nuts.
All right. Fred, are you just going to sort of, why don't we throw to you now that you're back, and you can tell us a little bit about your trip, because you've been away for, feels like 4 or 5 years. No offense, Jonti.
That was just one answer from me.
Okay, well, I won't go there, but the trip was pretty hard work, actually, because Marnie and I were leading one of her tours, actually 3 of her tours, 3 separate ones, which were all back to back. We started off in Sweden, went through far northern Sweden, far northern Norway. For the first time, I got to the North Cape, a latitude of 71 degrees. It's the farthest north I've ever been, I think. Then we went back down to Oslo, flew across to Reykjavik, and had a really wet and snowy 10 days, I think it was, 11 days in Iceland. Again, going to bits of Iceland that I'd never seen. The northwest in particular, some quite extraordinary places there, including one of the highlights was the place where astronauts used to go to train in the Apollo era, to train in geology. And there's a little museum there. It's basically a small town with at the end of the road, almost very not very much to recommend it under normal circumstances, but this amazing museum. And they get visits very frequently from past and present astronauts, which is fabulous. It was a great experience. And then we went from Reykjavik to Nuuk in Greenland, where we spent the last 11 days of our tour. Greenland is a totally fascinating place in every possible way. It is stunning physically. You have an ice sheet, which we stood right at the edge of, a few coastal towns, and wait for this, no roads between them, none at all. All transport between towns in Greenland is either by boat or by air. And we did it by air. So, some amazing stuff. What drove the trip, of course, were the chance to see sites like the Northern Lights, chance to walk on glaciers in Iceland and stand beside active volcanoes. And the thing that blew my mind in Greenland were the icebergs. Just astonishing. These, half-kilometre long lumps of ice floating past our hotel window as they carved off the Ilulissat was the name of the town where we were at that time, at the end of the Ilulissat fjord. Right at the other end of it is the Greenland ice sheet, and it carves off all these icebergs as you see them go past. I guess the other highlight was particularly in northern Norway and Sweden, and also again in Greenland, some fabulous sightings of the Aurora Borealis. We had some great times with that. Wonderful images taken by our whole group, and I got quite a few as well, using, sad to say, one of these. It's just unbelievable.
Yeah, they do take amazing pictures. I saw a couple. that you posted early in your trip.
Oh, good. Yeah. I've forgotten I'd done that.
Incredible.
It's 5.5 weeks, and so it's been a long time. It's been hard work looking after these wonderful customers that we have, some of whom might be listening to this, because a lot of our clients sort of came to us through Space Nuts. They're all fabulous people. We've enjoyed their company throughout. 3 different groups, 1 or 2 people in common throughout both of them, and had a great time. The ones who listened during my absence was telling me how great they thought Jonti is. And so that was good news, because that's why we asked him to do the gig.
Yeah, the check's in the post, Fred. Thank you.
So hard work, but very enjoyable. And I have to say, Marnie and I are sort of now recovering and facing the next big thing, which is Dark Sky Conference in Melbourne in about 2 weeks' time. So there's 120 people coming to that, and we'll be talking about all that kind of thing.
Yeah. Judy and I will be in Greenland and Iceland later this year. So we're really looking forward to it. We're actually doing an iceberg tour.
Yeah.
Out on, I don't know what kind of boat it is, probably one that'll get me wet. But really looking forward to that.
See, I think you should set the next trip or one of the future trips for that to coincide with Geminid Maximum as well. So Geminids are obviously the highlight of the year for everything. And being in December, that's perfect dark sky time. So you could sit out under the northern lights and see natural fireworks as well.
Oh.
There's always a special reason for watching the Geminids, Jonti, which you might not be aware of, but they peak on my birthday.
Oh, fabulous.
So it
makes me even better.
It's a natural birthday present.
Yeah. And they've just got better and better and better as well. I mean, I know when I was watching them in the 90s, they were very, very good. And they're still getting better on a decadal basis because the meteor stream's gradually talking round, and we've still not seen the best of them, so they're still improving.
Yeah, there you go.
Excellent. All right.
So just one final comment from me, if I may, Andrew, and that is thanks to both of you for holding the fort so well, and especially Jonti for jumping into the hot seat. It's been absolutely terrific. You being our favourite Dep and standby, and we look forward to welcoming you back in the.
I'm always happy to help. I'm just glad you had a good break. That sounds fabulous.
It's been great. I'll
show you how I've had to cope with Jonti.
Oh, right. Okay. Well, it's a downhill slope there.
Nice Merlot when it's 7 o'clock in the morning. No, hey, he's been terrific. He really has, despite the bad poetry I throw at him from time to time.
Yes, I look at that.
You gonna stick around, or you got to go?
If I may, I'll stick around. But it's Jonti's gig. I'm just going to sit in the background and enjoy it, if that's all right.
Yeah, all right. Well, we're going to talk now about Jonti's favourite punching bag, and that is SpaceX. What's the latest with them, John?
Yeah, I always, and I know I say this quite often, I try and take a fairly even-handed side of things when I talk about Elon Musk and SpaceX and what they do, because I think it's like all good characters in books. The best characters are not evil or good, but they're somewhere in between, and they do good things and bad things. But this week, I think we're talking more about the things that haven't quite worked right. So earlier on, I think possibly the first episode, I was substituting in, we talked about the Starship launch that went wrong, and everything went boom, and fragments fell over the Turks and Caicos Islands.
That's right.
And interestingly, there is a link to a pretty lengthy and quite startling article on CNN, which we might be able to put out with the podcast, from the 30th of January. I'd not really followed up on it, but people in the Turks and Caicos were complaining about the lack of engagement from SpaceX, the fact that they're finding debris all over the place. A car was damaged by some of it, and loads of it floating and washing up on the beaches, and nobody's made any efforts to contact them or collect any or do the cleanup. Now, that may have changed. SpaceX has historically been reasonably good at cleaning up its mess, but I was quite startled reading that article through at the level to which there was a bit of upset there, and that the photographs of all this debris washing up on the beaches was quite startling, when in the days after that, it was just said, it fell in the Atlantic. It went over the Turks and Caicos, but it was out in the open ocean. So that was quite sobering, but I only came across that because there was another high-profile SpaceX things didn't work as expected that's made a lot of the news over the last week, particularly on the BBC website, but also on space.com. Fabulous images again all over the app formerly known as Twitter and all over Blue Sky and things like this. Because one of SpaceX's Falcon 9 rockets, the upper stages of those are not reusable. These are the bits that go so high they can't just bring them back and land them. And typically they bring them back in a controlled re-entry. So they say, this thing is going to come back to Earth, but we're going to force it to deorbit at a time we want it to in a place where it's going to be far from land, keeping it as safe as possible. But this one in particular failed to come back in at the start of February and had gone out of control. So everybody knew it was going to come back in at some point, at some time, in some place, but nobody was really sure why. So it's like your typical failed attempt at being menacing, you know, at some time, at some place. In the indeterminate future, something bad might possibly happen, maybe. And then it did. So there's all this footage from Northern Europe, starting from kind of Lincolnshire in the UK, of yet another one of these space debris re-entry events. Spectacular, incredible scenes that people have shot. But the debris actually made it to the ground in fairly substantial chunks over Poland and potentially also over the Ukraine. Now, I've not actually seen any reports showing debris on the ground in the Ukraine, because obviously it's hard to get images out given all the other problems they're facing at the minute. Although, to be fair, this is the last thing that they need, is additional bits of metal dropping on their country. Yes. But there are lots of bits that fell over Poland, including one bit that was found that is 1.5 meters by 1 meter that damaged some lights and stuff around a warehouse. So this isn't just a bit of debris burning up harmlessly in the atmosphere. This, again, is stuff making it to the ground intact, which is where people get worried. And it ties in quite nicely with some of the things that were being reported back with the Starship launch. Some statistic that was worked out based on the frequency things were coming back in 2023 and our use of airspace, saying that there was a 26% chance in any given year of a major space debris re-entry event over populated, highly used airspace, and that's exactly what this was. The report a few years ago that said the likelihood of somebody dying from space debris in the next decade could be as high as 1 in 10. And this is a sobering reminder of that, because at the end of the day, if a bit of a SpaceX rocket that's 1 meter by 1.5 meter lands on your head, that's going to put a sizable dent in your day. And there is fabulous footage about this. And I think the thing that offsets this is that SpaceX are trying to do things right. To give them the credit, they're bringing things back in as much as they can in a controlled fashion. We talked about this with the Starlink satellites the other week. And on the whole, they're trying to do that right. Now, there are other concerns, things like the pollution side of it. But this is a big reminder that space is difficult. Things go wrong. And when we continue to put this many rockets up there, from time to time, some of them will come back in an uncontrolled fashion. And this is the second time just in this calendar year where significant chunks of debris have fallen over populated airspace. Bits have either landed or washed up on places where people live. You know, somebody's car was damaged in one event, somebody's warehouse damaged in another. It's not all plain sailing, I guess, is the take on from this. And there's a lot of fabulous coverage of it all over if you do a bit of browsing around.
Oh, yeah, and some of the pictures are incredible, and the footage, there's video footage and photographic material that shows, and over a wide area, very wide area, from England right through to Poland. These images have been published, and I mean, they're spectacular to look at, but the fact that big chunks are hitting the ground and doing damage, that is scary stuff. And Fred, you and I have talked about in the past, not only the threat or the potential threat to life as a consequence of this, human being killed or injured under these circumstances, but also what the impact might be in the insurance industry, because people may have to insure against this kind of thing.
We've got, sorry, Jonti, we've got Starship 8 coming up this week. Is that right? The launch of the next...
that's come around quicker than anticipated, and it's because SpaceX are very transparent in their efforts to understand what went wrong, so they've been able to escalate the approvals through. May or may not have anything also to do with the prominence of their owner at the minute and his strong connections. But yeah, I'm surprised that they're launching again so quickly after that went wrong. But they are very enthusiastic on testing things by destruction. They are quite rightly of the opinion that when things go wrong, that's when you learn the most, and that's when you can fix things and improve them. And they've done a fabulous job. That's how their whole business model has worked all the way through. But it still feels a little bit too soon.
Well, they're talking about the 28th of February, actually.
Yes.
As the next mega rocket launch. So,
and most of these things are streamed live, of course, aren't they? So you will be able to watch along with that if you're interested in that kind of thing. And I think that's another really positive that's come out of this. When I was a kid, launches were not as common, but you only ever heard about them on the news when something went wrong. And I remember as a kid, Challenger, I remember the other shuttle disaster during my PhD. But other than that, you couldn't watch it. It's not like it was live and televised. And yet now you can tune in, you can watch these things as they happen, both NASA launches, but SpaceX launches. It's fabulous. It's a great time to be alive.
Yeah. It's reached a point where people go to watch these things like they do.
Yeah.
Go to watch NASCAR races, and you only go for the crash.
Yeah.
So that's kind of where it's headed, sort of. And SpaceX hasn't disappointed. They've had several successful failures. So yes,
rapid unscheduled disassemblies. Is that what?
Unscheduled disassembly is another one. Yes. Anyway, Friday apparently the Starship 8 launch is scheduled for. So we'll see how that pans out.
It'd be interesting to see if anybody flying to Johannesburg with Qantas gets delayed with that one, because that was another problem with the previous one, because they are where they look to bring in the upper stage of Starship if it goes well is directly on the flight path from Sydney to Johannesburg. And so Qantas flights kept being delayed at short notice when SpaceX said, we're going to launch. Actually, no, we're not. Oh, no, we're going to launch now. No, we're not. Because you can't fly through the airspace where a rocket might hit your plane, even though the odds are vanishingly small.